Section that we're about to do is going to be extremely important to you moving ahead. We're going to do a little more than what we do in the workbook because as you get into grade 12, this is one section they spend upwards around 3 units of 8 on this material on trigonometry in grade 12 pre-calculus. So it's important that we get a really solid base of this year, and then it takes away some of the extra time that we have to spend next year on the explanations and some of it. The first thing I'm going to talk about is one thing that we've looked at earlier, even in the applied course. If I take the sine of 30 degrees, what do I get? I get a half, all right? That's the one that we always want to remember. What is the sine of 150 degrees?
Half.
You sure?
No, it's no. Yeah.
Yeah.
It's
negative.
Yeah. What'd you say?
Isn't it a negative half?
Negative half?
just regular half.
All right. The answer is it's 1/2. Okay. Now we know that because if you take the sine of supplementary angles, they're equal to each other. Now, why? Why is that? I've always said it happened, and I said it happened when we talked about ambiguous triangles, right? Where we had to decide whether we had 0, 1, or 2 triangles in the applied course. Well, now let's find out as to why that happens. And it works like this. When I take a coordinate system and I find an angle in the first quadrant. So if I take the angle of any positive ratio, so for example, let's say it's 30 degrees. That means that the ratio is opposite over hypotenuse is 1/2 in the sine graph, right? Well, if I take this, now this is what we refer to as the terminal arm. Okay, the terminal arm is the arm that makes the angle. Okay, if I extend that arm into this section right here, all right, and I create an angle of 150 degrees. Well, what does that make this angle between here and the axis then? It's also 30 degrees, right? And we already know from doing it in the first quadrant that the ratio is 1/2. So that's why the angle of 30 degrees here and the angle of 150 degrees gives you the exact same trig ratio. Because they still both complete a 30-degree angle with the axis that we're talking about in terms of x. All right, so the first thing that they do today is they talk about the initial arm. The initial arm is always the arm made with this axis right here. It always starts here. And then I think of it as 2 lines on top of each other, and then I move one of them to create the angle. And then the angle is this arm right here, or this arm right here is referred to as the terminal arm. So if they say, okay, what is another angle that's in the exact same position as the terminal arm of an angle of 30 degrees? So I want to know, where's the next angle that's going to create, where's that arm going to have to be in order to create an angle of 30 degrees? Well, if I take this arm and I move it all the way around to here, does it end up in the exact same spot? Sure it does. So what did I add to that 30 degrees? 360. So the angles that have the same terminal arm is 30 degrees and 390 degrees. And then I can add 360 or take away 360 from that point and still always end up in the exact same position. All right? Now, what you're going to do today, or for part of this, is you're going to want to find the reference angle always. Okay? Now we're going to get into great detail about all of this. Yeah. We're going to go into a much greater detail as we get going, but the initial one I want to look at is this. If I have this angle right here and I create 30 degrees, I refer this as my theta r, which is my reference angle. And the reference angle is always made with the x-axis. So to find 3 other angles one in each of the other quadrants that has the same reference angle, I do the same steps all the time. So for example, if I wanted to find out what that reference angle is over here, if that's 30 degrees right there, how do I calculate what this angle is? For me? Exactly. So if it's in this quadrant, it's 180 degrees minus theta r. Okay? Let's say I want this angle down here, which is just 30 degrees. How do I calculate what that angle is?
270.
Sorry?
270.
Not quite that far. Right to here. So how are you doing it? How do we find it? 180 to here plus 30. So it would be 210. Right? So it's 180 degrees plus theta r here. Okay? And down here, if this is 30 degrees, how do I get that angle right there? 360 degrees minus the reference angle. Okay, so what have I done? Well, when we talk about trigonometry, we talk about the ratios. The opposite over the hypotenuse, the opposite over adjacent, adjacent over hypotenuse, right? We're always talking about comparing ratios of sides, lengths together. I have just created three separate ways of finding the same reference angle and same actual trig ratios. So if I was talking about 30 degrees, then my ratio is 1 over 2. 1 of the opposite over 2 here. 1 over 2, 1 over 2, 1 over 2. The same ratios will occur on those very angles all the way through it. Okay? It says an angle theta in standard position an angle theta is in standard position when the vertex of the angle is located at the origin 0 and 0 on a Cartesian plane. The initial arm of the angle lies along the positive x-axis. The measure of the angle theta in a counterclockwise direction from the initial arm to the terminal arm. The quadrants of the Cartesian plane are labeled with Roman numerals, also counterclockwise direction beginning from the positive x-axis. So that's just this here. We all know that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4 over here. Right? Okay? Now, the next thing that we need to do, and this is the most important thing that we need to do, is we need to talk about two very, very specific triangles. What our objective is going to be is to solve questions without using the calculator. And I'm talking about trigonometric ratios. Can we find the exact value of the sine of 60 degrees? Can I find the exact value of the sine of 75 degrees? All right, that's what our objective is. And an exact value doesn't mean you punch in second function sine 75 because you're going to get a decimal. Is a decimal an exact value? Sure, if it stops. But all of those are going to give you irrational numbers, non-repeating, non-terminating decimals. So we are going to base all of our know-how on two triangles. The first triangle is this guy right here. Both are going to be right triangles. So our focus is on a 30, 60, 90 triangle. Okay? Now the first ratio I want to use is the sine 30. That's the one that we have been told to remember since grade 10. What is the sine of 30? What is that ratio? 1/2. 1 over 2. Right? Knowing that this is 1 over 2, what is the measure of this side right here? 3. No. What is the measure of that side right there? You're close. Pardon me?
2 squared minus 1.
2 squared minus 1, which is?
3.
What are you forgetting to do?
Oh, square root.
Square root 3. Right? Because Pythagoras' theorem says this squared plus this squared equals that squared, right? So then this guy right here is going to be 2 squared. The square root of 2 squared subtract 1 squared, which is square root 3. That's an exact value. It's of course an irrational number because it's a square root of a non-perfect square. But it's an exact value if left as square root 3. Now, we've done radical works in grade 10, where we work with just square roots. We don't change them to decimals, we just leave them as is, right? So, the first thing I want you to do is go like this. Sine 30 degrees equals cos of 30 degrees equals tan of 30 degrees equals. All right, what's the ratio of the sine of 30? 1 over 2. What's the cos of 30? That's right, Em. Square root 3 over 2. What's the tan of 30 degrees? 1 over square root 3. Now, last year we learned how to rationalize the denominator. Remember what rationalizing meant? It meant we don't want that root 3 on the bottom, right? So how did I get it so it wasn't a root 3 on the bottom? Times by root 3 over root 3. Right? Square root 3 on top over root 3 times root 3, which is? What's the square root of 3 times the square root of 3? 1. Okay? Square root 9, correct? What's the square root of 9? Maria said 3. So the tan of 30 degrees, we can either refer it to as 1 over root 3 or root 3 over 3. Either one is correct. What's the sine of 60 degrees? What's the cos of 60 degrees? What's the tan of 60 degrees? Opposite over adjacent. Root 3 over 1. All right? Now, I'm not asking you to memorize them, but I am. You need to know these. But you don't have to memorize them. All you need to be able to remember is that if you draw a 30, 60, 90 triangle, 1 over 2 is your opposite over your hypotenuse, and that is the sine of 30 degrees. That's what you have to remember. Okay? Now, doing this, we want to be able to write all of this into the different quadrants. But before I do that, I'm going to look at the second triangle. So there's the first triangle right there. The second triangle that we have to remember is this guy right here. Also a right triangle, except 45 and 45 degrees right there. Okay? Those are the same. They're ones. So if those are the same and they're ones, what does that make this guy right here? I2. Pardon me? I2. Square root 2. Yeah, good. Square root 2. Okay? What is the sine of 45 degrees? What's the ratio? 1 over root 2? What is that the same as? If I rationalize it. Very good. Root 2 over 2. Cos 45 degrees equals 1 over root 2 or root 2 over 2. I like these root 2 over 2s and root 2 over 2s. We're going to use them all next year. So let's get used to doing that. This one I don't care if you rationalize, the tan 30, but I do care if you rationalize this guy. I want to do that. All right, and then the final thing is, what is the tan of 45 degrees? 1 over 1. So those two triangles are going to be extremely important to you moving ahead. You're going to spend some time this year and a whole pile of time next year working with just those two triangles. And it seems pretty easy. Okay? All right, so let's take a look at page 57. So that's that. Now let's look at 57 and let's see how it applies to us. All right, first things first. Sketch each angle in standard position. State the quadrant in which the terminal arm lies. All right, 80 degrees. Sketch 80 degrees. What quadrant is 80 degrees in? First, right there, 80 degrees. Good enough. Next one, 120 degrees. Second quadrant, up there. What's this angle? That's the one I like to refer to. If this is 120, what is that angle?
60.
60 degrees. Right. Now that's important to us because if I draw it down like this, and if this angle here is 60 degrees, all right, that means that this is 30 degrees up here because this is 90. Looks like this, 1 over 2, root 3. I could label the whole thing. Except, that's going to be a negative right there. Because it's the negative x-axis. So that's later. And then finally, 266, which quadrant is 266 in? Down there somewhere. In which this would be 86 degrees right here. Okay? Nothing more than that for that first part. It says determine the reference angle for 315 degrees. Determine the reference angle for 315 degrees. So let's draw 315 right to there. That's 315 degrees. What is this angle right here? Because that's my reference angle. What is it?
36.
That's right. 315, which is what? 45 degrees. There's your reference angle. Now we don't refer to this. Our reference angle is specific to the first quadrant, but we will talk about it in terms of where it is on the x-axis. Okay, so that's the most important part. And the last thing, the bottom of the page on 58, determine the measure of all angles in standard position between 0, theta, 360 that have a reference angle of 35. So you have a reference angle of 35. So this is exactly what we did already with 30. So this is 35 degrees. That's my reference angle. Right? What does that make this angle over here? How do I get that angle? Yeah, how do I get it? 180 minus your reference angle. You're right. Okay, good. So that's 145 degrees. Down here, this is 35 degrees. What does that make this angle?
180 minus.
Not minus.
Plus.
Plus.
180 plus.
That's right.
Plus.
Lucas. 215. And then over here,
30, 60 minus. Yeah.
325. Okay, not that difficult yet. Right? Okay, so the biggest thing that you need to know and remember is these two guys right here. Well, not that one, this one right here. These two guys right here. That's what we have to take from today. This is the start of what is ultimately what you're going to spend oodles of time on next year. So we want to get a grasp of it right now, and we will go above and beyond this year so that when we get into it next year, it's just touching on it. It won't be brand new to you. Fair enough? Okay,